Okay, 15. Kaylee was riding the screamer, and once again it broke down. She had to climb 50 feet to get to ground level. What was her seat's angle of rotation? How many places could she have been sitting on the roller coaster? State all possible angles of rotation for positions between 0 and 2 pi. Be sure to show your work/thinking. Okay. A reminder, the screamer was just that giant Ferris wheel ride where the top half was above ground and the bottom half was below ground. The radius of this Ferris wheel ride was 100 feet. Okay, it was a really big ride. And what this problem is indicating is that Kaylee had to climb 50 feet to get to ground level. So here's a possible position where she could have gotten stuck. Okay, right here where I've drawn this arrow, that height would be 50 feet. And what we're looking for is this angle of rotation. So what is theta? There are different ways that we could go about this problem. We could use what we know about special right triangles, right? Do you see the pattern for a 45-45-90 or a 30-60-90? Or what else can you do? You can set up an equation. Sine theta would just be the opposite side over the hypotenuse. In this case, the opposite side is 50. The hypotenuse is 100. That simplifies to 1/2. So rewriting this down here, what values of theta would make this equation true? This is kind of like number 13 from the last slide. You could consult your unit circle here. So what angles on the unit circle have a sine value of 1/2? Let's see. I'm gonna erase some of this highlighting. Okay. Right here at 30 degrees, or pi over 6, whatever mode you want to use, notice that the sine of 30 degrees is 1/2 because it's always cosine comma sine. Okay, that is one place that Kaylee could have gotten stuck. But it's not the only place. We're not being told if she's above ground or below ground, or whether she's on the right side or the left side of the Ferris wheel. We're just told that she has to climb 50 feet. So she could be over here because this height is also 50 feet. She could be down here or down here. Those heights are also 50 feet, just negative. And so what we want to do is find all of those angles. And remember, there is a pattern when you're looking for the corresponding angles for a reference angle. Here, if our angle is 30 degrees, then these other angles would be 180 minus theta, 180 plus theta, and 360 minus theta. So replacing those thetas with 30 degrees, this is just 150 degrees, which is what we see over here. This is 150. 210 degrees, which is what we see over here. 210. And 330 degrees right there. So 30 degrees, 150 degrees, 210 degrees, and 330 degrees are all possible angles of rotation where she could have gotten stuck. As radians, that would just be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And looking at the unit circle, notice that the y-coordinates at those points are all a half. Below the x-axis, those are negative, but here we're just generally looking for where she could have gotten stuck. And that's it. That's it for number 15. Those 4 angles that we identified are our answers here.